Welcome to an introduction to infinite series. The goals are to define a convergent and divergent infinite series, as well as to determine if a series appears to converge or diverge. We will not be taking a look at specific convergent or divergent tests. Those will be covered in the next several videos. The main purpose of this video is to develop the idea of what it means for a series to converge or diverge. Since we just finished studying infinite sequences, it's important that we distinguish between an infinite sequence and an infinite series. Remember, an infinite sequence is just an infinite list of terms. So if we take an infinite sequence and then sum the terms, we have what's called an infinite series, as we see here. So to determine if an infinite series converges or diverges, we must consider the sequence of the partial sums. So what that means is, if we have an infinite series here, if we want to know if it converges, we're going to take a look at the sum of the first term, which would be just 1, the sum of the first two terms, which would be 1 plus 4, which equals 5, the sum of the first three terms, which would equal 14, and so on. And the question becomes, does the sequence of the partial sums, 1, 5, 14, and 30, converge or diverge? So the sequence is generated by the partial sums of the infinite series. It's probably pretty easy to see from this sequence, it appears as if this is going to increase without bound, and therefore this infinite series diverges. We'll take a look at a more formal definition in a few minutes. Let's go and take a look at another infinite series. Here we have the infinite series of 3 divided by 10 to the power of n. So when n is 1, we'd have 3 divided by 10 to the first. When n is 2, we'd have 3 divided by 10 to the second, and so on. And then we'd find the sum of these terms. Let's take a look at the partial sums in decimal notation. Well, the sum of the first term would just be 3 divided by 10, or 3/10. The sum of the first two terms would be 3/10 plus 3/100, which would be 0.33. And then the sum of the first three terms would be 3/10 plus 3/100 plus 3,000, as we see here in decimal form, which is 0.333. And you can see the sum of the first four terms would be 0.3333. So the question becomes, does the sequence created by the partial sums, as we see here, converge? It looks like this 3 is going to repeat forever, and 0.3 repeating should remind you of the fraction 1/3.